Greetings, everyone. Really stoked to have you here today, and welcome to our first summit and soft launch. As Graham mentioned, if you have any questions, please feel free to type them in the chat, and we'll try to answer them after the panel. And I would have loved for this conversation to be more interacting, but we'll also plan to send the slides over afterward. So here's what I believe are the three largest challenges that MarsU is addressing. The first one being the Mars education gap here on Earth. I believe this truly has a profound significance that can be really hard to determine how much an impact it actually has. And the second one being unexplored passions. I think no one wants our time and effort to be wasted in settling on this journey to settle and explore Mars. And so I think what we're really doing is building a community to really help you find those passions to help you make a meaningful impact beyond our biosphere. And then there's this lack of ideation and knowledge exchange between the older and younger generations. And I think the benefits of this communication interface is really underestimated in human history. Here's a glimpse into the future. We believe exploration and travel to Mars will be desired from mankind, and that a creation of a human civilization on Mars requires a significant more amount of time and research. Then there's also this time period where space agencies and organizations will be overloaded with data from Mars. Next slide. And so here we are to come and save the day. Here's our vision. Our vision is to educate, inspire, and empower humanity to create a habitable world and to extend human civilization to Mars. And how we'll achieve this vision is through our mission to unite students, researchers, and professionals in a multidisciplinary academic environment to settle the planet Mars. We've been on this mission for over the past half year to help start a Mars University, and it's three people and accomplishments have really inspired MarsU to come into existence. One definitely being Elon and SpaceX, and two being Robert's Case for Mars book, and three being a gentleman by the name of Bruce McKenzie, and volunteering with the Mars Foundation. And the fourth thing is that there's Bruce. The fourth thing being that I was kind of itching for this education myself. So, and when I hear the words Mars University, I think of a commitment to pass on the knowledge and to expand on the research that our species has made over the last half century. And I think MarsU definitely would not exist if it weren't for the accomplishments of NASA and SpaceX and the entire space community. But I think part of the problem is that myself and a lot of other people, they want to help, but we're not quite sure how we fit into the puzzle yet. And we believe that our students, faculty, and alumni could really make a meaningful impact on settling and exploring Mars. Some would argue that a Mars university is premature and that Earth is not ready. I would argue that the earlier the better, and that it's about damn time for Mars academia. I'm a strong believer that our species can accomplish anything that we put our mind to, and that knowledge comes first. And I believe this is a good next logical step to in our evolution to become multiplanetary. See, I'm doing on time. Okay. 5 minutes in. So here's how we're designing and organizing this 5-week Mars summer program next July in 2021. And who it'll be, we're planning to host around 50 to 60 students who are undergraduates, graduates, and young professionals, open to executives as well, with over 6 instructors and 20 to 30 amazing speakers. And we're planning for this program to be inclusive of all backgrounds, majors, not just science and engineering. And the what, we're organizing a certificate-based, project-based, in-person program, which we believe would be preferred, and that in terms of the knowledge retainment, that in-person really has a meaningful impact. But if it comes to it, we're open to providing this program online as well. And we're planning to provide 4 Mars-oriented courses. The first one being Mars 101, an introductory course that really covers a lot of the subjects and topics outside of the 3 other courses, which will be determined from the 3 areas of study from our interested students and applicants. We'll have interactive lectures, workshops, and team projects, and we're really looking forward to this transformational experience. And I'm really excited. More on the program, we're looking to provide a detailed technical overview on the science, technologies, and the post-arrival activities, with an emphasis on both the robotic and human settlement and exploration. And then following the program, students will have the option to engage in this mentoring or professional experience, such as a analog mission at the Mars Desert Research Station. They can engage in research with and shadow at local companies, and which could potentially lead to internships. We think we're unique because we're planning to be more affordable and hands-on than other similar programs. And I strongly believe that this program will directly support the Artemis Moon to Mars program. And here's more about the MDRS. It's operated and founded by the Mars Society in 2001. And they've had 230 crews, and they're just outside of Hanksville, Utah. And it's run by our co-founder and Dr. Shannon Rupert. Okay, moving on. So on the right here is Marth Vallis. It's a valley on Mars with a significant amount of geodiversity, and on the left are massive lava tubes that could be inhabited soon. And here's our application timeline. We're planning for applications to open on November 13th and close on January 15th, and with scholarship applications due February 12th. We're also planning to have 1 or 2 online events in late November for a more open discussion with interested students and applicants. And we would like your CV to be tailored as if you're applying to be an early settler on one of the first crewed missions. And then here are the application details. We're working really hard to provide scholarships for around 20 students. Yeah, tuition will be reasonably priced. It's definitely contingent on the conversations we're having with potential host universities. And we've been having some great conversations with ASU about co-hosting this program with their School of Earth and Space Exploration. And moving on. Okay, here are, here's our 3 co-founders and people I've come to really admire. This is Dr. Shannon Rupert here. She's the director at MDRS, and she's highly knowledgeable about astrobiology and analog missions, and has over 20 years of experience working at NASA Ames. And here's Bruce McKenzie.
Hello.
He's the founder and director at the Mars Foundation, and is one of the most knowledgeable humans I know about Mars settlement and agriculture. And there's me. And here are our 4 amazing advisors we've been working with over the last half year. And our amazing faculty. If any faculty are on the call, it would be awesome if you could introduce your name and skills or what you're knowledgeable about.
Well, I'll start first, since I'll be speaking here shortly a little bit about some of the classes we're offering. But I'm Dr. Graham Lau. A lot of you know me online as the cosmobiologist. I'm a public speaker and science communicator, also an astrobiologist with expertise in geochemistry and mineralogy. I've spent a lot of time thinking about how our analogs on Earth in various environments can help us learn more about looking for life on Mars.
Cole, do you want me to talk now, Bruce? Okay, I'll take that to be yes. So I'm Bruce McKenzie, one of the founders of Mars University and also the Mars Foundation. I'm active in several organizations, including Mars Society. I've got a background in architecture, computer science, and graphics, including EIT. I designed the first serious masonry structure on Mars. I needed tens of materials. Let's see, that led to the hillside settlement design, one of the first series designs for a permanent Mars settlement. Depending on the interests of students who are enrolled, I can cover architecture for permanent settlement, I can cover construction from local materials, structural engineering, 3D printing, and especially the limitations of 3D printing, why you don't always want to use it.
Thanks, Bruce.
For example, if a lot of people do not have an engineering background, I can cover structural engineering without using math. That is, how to figure out how thick a material you need without getting into a lot of math. But if people do have an engineering background, I can go into a lot more detail. And I can cover aesthetics, usability, greenhouse design, and etc. So thank you.
I'm James Burke. I'm the IT director of MarsU and of the Mars Society. I'm a former Microsoft software engineer, and I'll just be helping out with all the technology we need for putting on all the academic programs. I'm pretty skilled with learning management systems, so be helping out there wherever I can.
Hi, I'm Nicole Willett, Vice Chair of Marspedia and steering committee member for the Mars Society, and just general overall Mars expert and educator. And I'll be speaking to you all in a bit.
Thanks, guys. And is Shannon or Catherine or Daniel on?
I haven't seen them.
Okay. Okay, cool. One of the last things I wanted to mention, we would love to discuss collaborating with professors who are knowledgeable in engineering and manufacturing, rocketry, and Starship, and governance, economics, and ISRU. And so we'll pass on the torch now to the astrobiologist and the communicator of science, Graham Lau.
Oh, I was unaware I was speaking right now. Hold on a minute.
So Graham, while we're getting ready, if anybody on the call would like to recommend guest speakers, we do want to have a lot of guest speakers on different topics, but we don't want to focus on that. But anyway, we are still open to suggestions.
All right, so I'm going to take over the share screen here. So going into this, so from my understanding, this was an interest survey that was sent out to a large number of people who are here and others to gauge your interest in the Mars University and to ask what kind of subject matter you want us to cover. And so these are the responses from 80 plus participants in the survey. You can see generally where they were located in the world, US, Canada, in Latin America, South America, nations in Africa, South Asia, like India, Japan. And so these are kind of a small sampling of our international audience of people who are interested in participating. I did see some questions about whether or not international students can participate, and yes, you absolutely can. And these are basically what people kind of want to learn about the future of Mars and how they can take part in the future of Mars. So engineering and manufacturing for Mars, factors in human health. How do we take care of people going to Mars and habitats on Mars? And how do we build a future for humans on Mars? And that includes our architecture, our settlement design. How do we actually build the places people are going to live on the red planet? And this little word cloud came from the recommendations from the participants in that survey. It comes from the things they think they want to see in courses about Mars. So things like robotics and communication. This ISRU in the middle, in situ resource utilization, is a huge topic. How do we go to Mars and use the Martian environment itself to build our habitats, to get our air, to live on Mars? Many of you might know that right now MOXIE is an instrument going to Mars on the Perseverance rover, and it's going to be a test of this in situ resource utilization, taking CO2 from the Martian atmosphere and breaking it down to make oxygen for breathing and for rocket fuel. But there's a lot of other things here as well. People mention things like inclusion, so bringing people together, sustainability. How do we actually build a future for all of us together on Mars? And that's a huge question. And we have a lot of other things here in science and humans and planetary issues. And so the courses that we're thinking of right now for developing for everyone, we currently have some set faculty. We're also potentially looking for more to bring you as many voices as possible, as many perspectives as possible, and as many backgrounds as possible with expertise in Mars. And so for myself, I'm an expert in astrobiology and how we use Earth analogs to look for life on Mars. But I'm also super intrigued by things like terraforming, settlement design. How do we grow plants? How do we grow food for humans on Mars? Also, how do we mitigate the radiation environment? We learned with the RAD instrument, the Radiation Assessment Detector, on the Curiosity rover, that the radiation environment getting to Mars and on the Martian surface is more than we had thought previously. And so how do we help humans to survive that transit to Mars? How do we build our settlements, our structures on Mars, to utilize the regolith, to utilize lava tubes and things like that to protect people from this radiation issue? And so we're working right now on developing the course structure for the first 5-week program. And this will give us a chance to kind of explore some of these topics in a course format, working with students to explore a lot of these really interesting topics about the future of Mars exploration. And so the general timeline that's being looked at right now by the founders and by us faculty is currently we're looking at having some seed funding starting off later this year to help us prepare for the very first summer program. We're looking at next year in 2021 in the summer. And again, that would be a 5-week program with a bunch of different courses in getting humans to Mars and living on Mars, as well as things like politics and governance of Mars, the philosophy of and the culture of why do we go to Mars? Why do we want to explore together as humans doing these things? There's also a plan then to have a second summer program after that first test program next year. And so both of these programs are things that everyone watching right now could apply to. And then the hope is that by 2024, we'd have then a longer, perhaps 9-month to 1 year-ish kind of program, you know, kind of set to be like a single year master's program focusing on Mars with our open campus at that point, assuming we bring in the necessary support for that to happen. And so this is a really cool quote to kind of end on here, that education is the most powerful thing that can change the world, and not just our world, but the red planet as well. We together as humans can choose to build a future for ourselves that includes being multiplanetary, being on Earth and being on Mars. And so we were hoping to have Janet Ivey and Dr. Robert Zubrin with us. Janet Ivey unfortunately can't make it. I think Dr. Robert Zubrin is going to try to join if he can. But as of right now, we're going to open it up to questions that you might have about this idea of the Mars University. And so right now, myself and Nicole Willett is going to join me. We'll be having a conversation, trying to answer your questions and talk through some of these things. And hopefully also you can tell us what we can do to make this better, what you want to see. We'd really appreciate that as well. And so I will introduce Nicole now. Nicole Willett is a subject matter expert in all things related to Mars, astrobiology, planetary astronomy. She's the vice chair of MarsPedia.org, and she's a full-time science educator who specializes in STEAM, project-based education. And so with that, I will jump out of this presentation and stop my share so we can have a conversation.
Hi, everybody. I'm Nicole Willett, and I would like to ask Cole a question first. So we're going to throw him into the weeds here. I know that the Mars Society has a conference coming up in October, and can you tell me about the Mars University's participation in that?
Yes, absolutely. We had a good call with Dr. Robert Zubrin a few months ago, and we're really glad to be invited to give a 60-minute panel at the Mars Society convention in mid-October, I believe, and so we'll be discussing more about MarsU and this 5-week program we're organizing, and really the benefits and need of Mars-oriented higher education. Thanks.
Great, that's awesome. So the Mars Society has its conference. You can go to marssociety.org and register for the conference there. We have over 2,500 people signed up for that, and you guys will learn a lot, maybe inspire you to go to, oh, Zubrin, Dr. Zubrin has joined us. Excellent. So we'll give him a second. Graham Lau he already introduced himself, but I would like to introduce him again. An astrobiologist and communicator of science. He serves as a research scientist with the Blue Marble Space Institute of Science, as the director of logistics for the University Rover Challenge, and as the host of the NASA-funded show, Ask an Astrobiologist. And I'll also introduce Dr. Robert Zubrin. He is the founder and president of the Mars Society and has collaborated with NASA and SpaceX to advance a human mission to Mars, as well as many other things he's done. So, Dr. Zubrin, are you there? I'll give him a second.
Unmute there. There you go.
All right, there we go. All right. So,
Hi, Robert. This is Nicole. I'm gonna ask you a question.
sure.
Ready? Okay. As a former educator and as the president of the Mars Society, can you explain why Mars University is an important step towards a human mission to Mars?
Well, look, one thing that's very important about human missions to Mars is what they're going to do for education. That is, youth loves adventure. And a bold reach towards Mars, if this is what our society is doing, whether it's doing through NASA or through private initiatives, it doesn't really matter. What matters is that we are doing it. This makes science the great adventure. And, you know, we saw this in the 60s when the number of science graduates in the United States, science, engineering, doubled and in some fields actually tripled because of the Apollo moon program and the sense that we were embarking upon a great adventure of science opening the future. And so, as I said, we've benefited from that intellectual capital ever since. And to me, this is the most critical thing. You know, I was a teacher for on and off for about 7 years between when I graduated as an undergraduate and when I went back to graduate school to learn engineering. And I taught in a variety of schools of different qualities from top to bottom. And one thing I learned doing that is the following, is anybody who can teach kids who want to learn and nobody who can teach kids who don't want to learn. And it doesn't matter whether you've got LCD projectors or you're using chalk. None of that stuff matters at all. Okay, it doesn't matter whether your textbooks are falling apart or they're the latest thing and every kid has an iPad, although no one had an iPad then, but you get the point. Do they want to learn? It's all about morale. And so, you know, right now they're trying to improve STEM education in the United States by implementing ever more standardized tests or this sort of stuff, which does no good at all. And in fact does a lot of harm. And beyond a certain limit. And so the Mars University is really an example of it's taking the Mars mission, even while it's still being seen as something in the future, and yet using it for the purpose. It is going to show everyone, I mean, it will benefit directly the students that engage with it, certainly. So it will have concrete benefits for those who are involved in it. But more than that, it's going to be a societal example. It will be the proof. And, you know, if simply the prospect of a Mars initiative can do so much good, imagine what the reality could do.
Thank you. And great point about culture and morale and desire to learn. As a teacher, I've taught at a lot of schools where they had all the fancy technology and schools where it was just chalk. And I can tell you, it makes no difference what you have. I agree with you completely. If you have the desire to learn and the school culture is appropriate, you're going to learn one way or the other. Okay, thank you for that, Dr. Zubrin. Dr. Graham Lau, why are the classes Mars University is offering awesome, and why should the students want to take them?
Fun question. One, they're awesome because we are going to do our best to run the whole gambit of what's possible, what we need to prepare ourselves for Mars. Many people amongst our students will be the first people going to Mars. And so we need to be ready for how do we build the right rockets? How do we get to Mars? How do we protect human beings on the way to Mars? Once we get there, how do we build the right habitats for exploration and eventually for settlement? And I noticed some questions about things like astropolitics and stuff like that. Absolutely. We need to talk about the politics, about the governance of Mars, what the future is for governance of Mars, when Mars becomes a sovereign planet of its own, and what happens there, and what those Martian people will decide. And so we'll talk about that in the classes. Also philosophy, culture, what drives us to explore, what makes us want to go out into the universe and go explore Mars. These are also important topics. And for myself as an astrobiologist, we'll talk about the potential for life on Mars and some of these issues in planetary protection and how some people don't want us to go to Mars because they're afraid there could be life there. I, for one, am a fan of the idea of making parks, preservation sites on Mars while we get our butts there and start exploring. But there's going to be a lot that we're going to cover in these classes. In a 5-week program, we're going to do our best to give you the full range of what's needed in engineering, in science, and in being human to get to Mars.
Okay, thank you, Dr. Lau. A question from Bruce McKenzie for Robert Zubrin. Some time ago, you mentioned what it would be like for the first children growing up on Mars without formal schools, but surrounded by well-educated people and helping with cutting-edge science. Can you expand on that?
Well, sure. They're going to be in a culture of science, a culture of creativity in general, both institutional and technological. A culture of inventors. And so you can learn, well, certainly not only a lot of science that way and engineering, but learn creativity. This I think will be a terrific education. I mean, frankly, I'm a fan of public schools. They have transformed America. They've transformed the world. They've created mass literacy. But it should be understood that they are a second best alternative to, which unfortunately it cannot be implemented universally, but wherever it can be implemented is tremendous, of children learning by, working alongside adults and being taught directly by people that are doing something. Thomas Edison's formal education went to 6th grade, but he was growing up in a frontier culture of technical innovation. And yes, he got some additional formal education from his mother, who was a school teacher, in fact, but and she inspired him to be a reader. But once again, that's being around an intellectual person, but he was also around the telegraph office and learning about telegraphs and all the problems associated with them. And his first invention was a way to make them better, actually 4 times the data rate. And there's going to be the culture of Mars. And I don't think that, not having formal schools where bells ring and you move from this class to that class every 45 minutes is an impoverishment if it is replaced by something far more personal and dynamic.
Okay, thank you, Dr. Zubrin. Dr. Lau, I would like to ask you, to discuss the types of professions that will be needed once we lay the groundwork for human missions to Mars, from planning on Earth all the way through the infrastructure once we are on Mars.
Absolutely. We need everyone. We need everyone from all backgrounds to help us make this happen. We need the engineers who can make the best rockets, who can make the best equipment, the best spacesuits. We need engineers who can figure out how to solve these tough questions of how do we get humans to Mars? How do we build the right habitats? How do we protect humans on Mars? How do we feed them on Mars? And they need to interface with the scientists who are looking for life on Mars, who are trying to understand the geology of Mars, who are trying to figure out how we'll grow plants and maybe other things for us to eat on Mars. We're going to need people involved in law to help us figure out how to make sure we're doing the right things when we go to Mars legally. And for the future of human settlements, we'll need to figure out the politics of how we actually organize ourselves there. I love that Robert brought up this idea of the culture of Mars as well. My friend Moshe Rhodes gave a really cool talk many years ago. He was talking about his faith as in Judaism and the issues that there are a lot of religious practices and cultures on our planet that rely on being Terran, on being on Earth. For instance, there are a lot of calendars that are set by the phases of the moon and not by the orbit of our Earth around the sun. And so when we go to Mars, will we create new cultures, new religious practices and beliefs around Mars and its two smaller moons? I had a great chat with Sasha Sagan recently about this as well. She's written a really wonderful book on ritual and how we find ceremony in our lives. And I think the first Martians will have to develop their own culture, their own rituals for being Martians and for finding themselves on the red planet. All the things that we want to do are going to require a lot of people working together to solve these questions, to innovate, to really figure out how do we do this. And also, we need people right now who are arguing the case for Mars to get us there now. We need people out there right now. We need active supporters, people who will advocate and get out there, who will write letters to their politicians and their countries around the world, who will talk to their friends and family and neighbors and communities about the fact that we can do this now. We can start getting humans to Mars right now. We don't have to wait another century. And if we start doing it now, we're going to be pushing ourselves, as Robert has often mentioned, into this frontier. We're going to be pushing a new frontier and building new innovation, new technology, new techniques and practices and methodologies, new ways of being human. And so my greatest argument is that Mars University will be for everyone. And the hope is that all of you, whatever your background is, even if you're not an engineer or a scientist, if you're interested in law or art or music, whatever your interest is, whatever your career is, we want to build the future for all humans on Mars. And so the idea here is to really develop classes to sculpt the education in a way that prepares all of us together to make this happen. Oop, you're still muted there, Nicole.
Thank you. I would like to ask Bruce McKenzie a question. Bruce?
Yes, hi.
I would like to ask about Mars University may become a center for analog research for permanent settlement construction and
right. Yes, yeah, thank you. This is something we talked privately about during the planning, and it wouldn't happen in the first summer session, but there's a lot of analog research about missions to Mars, where you go for, say, 500 days or even as low as 30 days. But there's very little research and hands-on work, hands-on analog sites for permanent settlement. How would you actually take the resources, the regolith in the air and the water in the permafrost, and do construction? So I could see a research arm of Mars University evolving where we maintain a analog research site to to test construction techniques, test material science, and possibly very long-term living situations. I think living on a frontier would be very much like 100 years ago, living in up in Alaska, where, by the way, I was living there as a child, or 200 years ago in the American West. So anyway, I could see Mars University branching off into that and becoming the leader in settlement research and maintaining an analog site. Thank you.
Thank you, Bruce. Dr. Zubrin, when we did the questionnaire for the potential students, one of the main and most, the answers we got the most was about robotics and how will that play into something like humans to Mars. Can you discuss the importance of robotics in a human mission to Mars?
Well, sure. Look, a human mission to Mars is going to have a relatively small crew, whether it's 4, as I proposed in Mars Direct, which I felt was the minimum viable crew, or 6 in some NASA missions, even if you had 10 or 20, as might be possible with starships, and even a Mars colony of 100 people or 1,000 people or 100,000 people will still have an extraordinary labor shortage, both in quantity and in variety. It just doesn't have the division of labor that we have on Earth. And so we also had this on the American frontier, where you had an extreme labor shortage, and in America in general in the 19th century, which is why immigration was encouraged strongly, and it was why wages were much higher here than in Europe, not merely to encourage immigration, but simply as an economic fact of supply and demand. And it's also why there were much fewer restrictions on admission into professions, because in a situation where you need, if someone has a skill, you want to use it and not put an artificial obstacle to the exercise of human ability. But even so, there was a tremendous drive here in America and in the frontier for labor-saving machinery. Now, there's going to be certainly a drive for labor-saving machinery, automation on Mars. But one step beyond that is robotics. A robot is a labor-saving machine, but it's one of a lot more versatility than, a drill press or a bandsaw or, any number of other devices that were created in order to save labor. Well, a robot can save many additional kinds of labor than simply a machine tool can. And then if we go beyond that, there's even artificial intelligence. And what is artificial intelligence really? It is a way to enable a human or a robot to engage in a larger variety of skills. It is something that can allow an ordinary person to, fix mechanical devices or engage in medical procedures or solve all kinds of problems that he can't without this assistance. And so I think that Mars will be, the Martian culture will be absolutely driven towards one, liberation of human potential, which includes eliminating artificial barriers to the exercise of human potential, i.e. red tape, but also the development of labor-saving machines, robots, and artificial intelligence. I think it will be, that will be its specialty. And in the course of doing that, it will, without question, develop numerous technologies that can be patented and licensed on Earth, and this will generate income for the colony as well.
Thank you. And the next question is for Graham, and it's about vegetarian cooking and recipes as we send humans to Mars.
Yeah, that's a really cool topic, right? What are we going to eat on Mars? I recently moderated a panel for Explore Mars that included Cyan Proctor, Rafael Herrero, Morgan Arena Irons. We had a great conversation about how do we grow plants in the Martian regolith. For instance, all those perchlorates that we've discovered in the Martian regolith are actually a problem for growing plants. So we have to treat the regolith and make it more suitable for growing plants. My friend Raphael likes to say that Mark Watney would not have survived those potatoes in the Martian, but it's still worth our time to figure out how we're going to grow our plants there. And yes, our recipes, how are we going to embrace making food that humans not only need for sustenance, but also that they enjoy eating? And that's a huge question, developing recipes for our Martian food, not only on the way to Mars and our spacecraft, that's not so bad, that's a short trip. But if you're on Mars for a year or many years, or you're in a settlement, you're staying there, how do you have a fun relationship with food? How do you enjoy the act of growing your food, of cooking your food and eating it in the same way that we do here? There are things on Earth that I love for food that I would miss so much on Mars. And I would hope eventually we could grow them there and do those things. But yes, there are people who are thinking about the best recipes for food on Mars. And so the question, I mentioned vegetarianism as well. You often hear us talking about growing plants on Mars, and we're not really talking about taking cows or pigs to Mars to have meat. But people have thought about, with the upcoming lab-based meats, will we be able to grow, beef in the laboratory on Mars in our settlements? Will we grow fish, fish meat, the muscle itself, not the actual fish, but the fish meat in our laboratories? And those are big questions as well. So we might not be solely vegetarian on Mars. It might be that part of getting to Mars is developing these lab-based meats even further. And so that's a really cool question. And yes, we definitely want to consider, how do we make really awesome food for eating on Mars?
Thank you. And I think people are growing full-grown animals outside of the uterus in vats of liquid. And I think that's a potential possibility for the future as well, which is, great for us carnivores. Don't at me. Okay, Dr. Zubrin. This is a question from Bruce, and he would like to have you talk about seniors in college, grad students. What types of courses and research should they be gearing toward if they wish to go to Mars or support a human mission to Mars? I'm sure there's a million answers to this.
The most obvious ones are in engineering and the natural sciences. That is, if we're talking about initial Mars exploration, we'll need engineers. We'll also need people who are really engineers but are not ordinarily called that, such as mechanics and other, hands-on makers. And then natural sciences, with one of the top of the list being geology, but also microbiology and so forth. Medicine will be useful. And then as we move towards settlement, people who know how to farm, and which isn't necessarily, yes, university agronomy graduates and biotech graduates, but also people who grew up on farms and know how to farm, or know how to do greenhouse gardening. It's a craft. There's lots of ways to have knowledge. Formal knowledge certainly has its place, but informal knowledge absolutely has its place. But as Mars develops from exploration to a base to actual settlement, then we're talking about creating every kind of human institution. Of course, once there are children on Mars, we're going to want to have teachers on Mars, but we'll want to have every kind of cultural institution. We're going to want to have community theater and community orchestras. So we want to have actors and musicians on Mars. And certainly we're going to want to have writers on Mars and creative people of every kind. But all the people that help create a viable society will eventually be needed. But if you want to be part of the first wave, to return to it at hand, if somebody's in school right now, it's science and engineering.
Thank you. All right. For the audience, I'm going to ask one more question of each panelist, and then we're going to go to the audience questions. Okay. So Dr. Lau, can you discuss terraforming and the current plans, if any, for terraforming, and how long it'll take, what's important about it, what are the logistics of such a big undertaking?
Yeah, that's a really fun topic to talk about. And it's something that we've dreamed about for a long time. We've written about it in our science fiction, and we've talked about it in our science as well for a long time. Can we make Mars a more livable environment for humans? And sometimes you hear people saying it will take, tens of thousands or hundreds of thousands of years to do that, whereas others of us think that we can do it a lot faster. If we apply the right resources, the right technologies, and if it's something we actually choose to do and want to do. There's a lot that comes with it, again, in politics, in culture, and the ethics. Like, should we do this to the red planet is a big question. But for us to become multiplanetary, a big part of that would be making Mars more habitable for humans. So terraforming is a great way to do that. It would be a slower process, most likely at first, but the idea would be to get to the point where we can walk outside in the Martian atmosphere without wearing a spacesuit. Maybe just wearing like a respirator to help us breathe the air a little bit better. And I think it's entirely possible and doable. And I think many of us here in this meeting probably agree with that. The question is, can we actually get people to innovate, to do this and make it happen? We have science right now that we can do this on Mars. There have been a lot of ideas presented over the last several decades of ways that we can start changing the Martian atmosphere right now to drive global climate change, to geoengineer the red planet in a way that makes it more sustainable for humans to live there. And so one of the big things about the people who attend MarsU is they'll have the chance, if they're interested, to also help us answer that question. How can we terraform Mars? Part of MarsU will include some project-based work. And maybe some of our students will want to work on this question. How do we terraform Mars? Maybe someone right now watching this panel talk will be the person who figures out the right innovation, the right technology that we need to make it happen faster, and will help us advocate to make it happen. And so I think long-term vision, like Robert said, the first humans going to Mars, there will only be a small number. It'll be exploration, going to Mars. But eventually we want to send humans to settle on Mars, to live on Mars. And down the road, they might actually want to develop their own culture, their own society, their own civilization on the red planet. And they might be the ones who really want to geoengineer their own world. And so it might end up becoming something that the Martians themselves are choosing to do rather than us humans telling them to, or us here on Earth telling them to. But that might become the case, but we better prepare now and be ready for it. And so I think someone watching right now who wants to be involved in this and join MarsU could definitely help us answer that question.
Thank you, Dr. Lau. Dr. Zubrin, speaking of terraforming in the way to heat up the Martian atmosphere, that kind of brings us to energy sources. So can you discuss the types of energy sources, how we're going to live off the land, as you always famously say, versus, Elon Musk's idea of nuking the poles? How do you feel about nuking the poles, and how do you feel about the energy sources that we will use on Mars?
Well, I don't think that nuking the poles will work as a method of terraforming Mars. I think even if you applied the full arsenals of the nuclear powers to the job, you would not have enough energy using that. And furthermore, you're not going to get those arsenals, so just forget it. The way we're going to warm Mars is how we will do by design what we are accidentally doing on Earth right now, which is we'll create a greenhouse effect. Except that if you want to create a greenhouse effect, there are more effective ways to do it than the current global warming byproduct of industrial society on Earth. That is, we know of some extremely powerful artificial greenhouse gases that we could manufacture for the purpose of driving global warming, things that are thousands of times more effective than CO2. And one of them, for example, is CF4, sometimes called perfluoromethane. But fluorocarbon gases like perfluoromethane are fantastically powerful greenhouse agents, and they are also resistant to destruction by ultraviolet, and also, unlike fluorocarbons that have chlorine in them, they don't destroy ozone. Now, if we manufactured these on Mars on purpose for the purpose of greenhousing the planet and applied about 5,000 megawatts of power to the effort, that's a lot. That's about the same amount of power that powers Chicago. Half the power that powers Los Angeles. We could produce these kinds of gases at a rate sufficient to raise Mars's temperature by 10 Celsius in 50 years. So really, if you want to know, the energy that is heating the planet is not the nuclear reactor, and certainly not nuclear bombs. It's sunlight. It's just we're much more effectively capturing the energy that's coming from the sun, which is terawatts of power, and the millions of megawatts of power is coming from the sun, but most of it just radiates away. When you have a greenhouse effect, you capture that. Warming the planet's a big job. So we use the nuclear reactors to make greenhouse gases, and we use the greenhouse gases to warm the planet. Now, but in terms of industrial society in general, for all the materials they're going to need on Mars and empowering the society, we're going to need power. Now, you can get some energy from solar power, but solar power on Mars is only 40% as strong as is on Earth, and it's somewhat unreliable due to dust storms. So while that can be used for certain purposes, Martian civilization is going to depend on nuclear power, both fission initially, because that's what we have now, and I believe eventually fusion. Fusion is very attractive for Mars because on Mars, deuterium, which is the fundamental fuel of fusion, is 6 times more common than it is on Earth.
Okay, thank you. And for Cole, and then maybe Graham second, this is kind of a 2-part question. All right, Coleman, how do the students apply for this program?
Yes, that's a wonderful question. Very important. If any people are interested in applying to this program, go to MarsU.space, and we'll open our applications under the academics tab, and there will be apply buttons available starting in early to mid-November, in a few months. And we're really excited and hope you consider applying.
And this might be for Dr. Lau, will we have classes on space policy, space law, astropolitics?
Yes, we'll definitely consider that. So most of our classes, much as what we need to get to Mars and to get humans to Mars, we focused in engineering and the science of Mars and the science of getting humans to Mars. But we'll also consider things like astropolitics, the law around current treaty here on Earth right now that's helping or hindering us in space, and the issues right now. Someone can go to Mars right now and claim a Mars rock as their own. There's no law stopping them right now from doing that. They can go claim Mars if they have the rocketry and they want to go do it right now. And so we need to figure out here on Earth what protections, what law do we want to preserve Mars for exploration, for human settlement. As I mentioned earlier, there's been this idea presented before about parks, making some planetary parks on Mars. Could be a really cool idea to preserve parts of the Martian landscape for the future, for future generations, much as many nations have national parks and wilderness areas and preserves. And there's also a lot of law about what happens on Mars. And when we have our very first settlement on Mars and someone commits a crime, what's going to happen? We need to be prepared for that. So yes, there's a lot in politics, a lot in law that we need to consider. And as I mentioned earlier, we also should talk about the culture, the history of Mars. Why do we want to go to Mars? And honestly, not everyone on Earth does want to go to Mars. Some people think that we shouldn't do this. And so we need to have that conversation. we need to have many of us from different backgrounds, different perspectives working together to have this conversation. And so MarsU will include some of that as well. And even though most of our classes, again, we focused in the engineering, in the science of getting humans to Mars and keeping humans on Mars, there are all these other very important peripheral topics that are super important and we definitely will talk about. We'll also have a lot of guest lectures, a lot of other voices from people from around the world who are really, experts in various realms related to Mars, who will be giving talks as well to share their knowledge, to share their voices. And so I'm really excited for the program. We're still working on figuring out the exact course structure, so I can't really say that yet. But there's going to be so much really cool stuff involved in getting humans to Mars.
Thank you. Dr. Zubrin, I have a couple of questions I'm going to combine about which we sort of already touched on with terraforming in the hostile Martian atmosphere. But somebody else asked about, does terraforming include making Mars have a stronger magnetosphere? And I think that's a really good question. And I'd like to hear your thoughts on how can you make the Martian magnetosphere stronger?
It would be very, very hard to make the Martian magnetosphere stronger. So people say, well, then how can you terraform it? The solar wind will strip away the atmosphere. Yes, it will on a time scale of hundreds of millions of years. And I mean, you got to realize that Martian atmosphere right now is about 1% of Earth's, and it's order of 1% of what it was 3 billion years ago. So that means that it has decreased by a factor of 10 every 1.5 billion years. And if you work the math on that, it means it takes like 100 million years to have any appreciable erosion of the atmosphere by the solar wind. So these are very long time scales compared to things of human interest. I mean, modern humans have only existed for at most 200,000 years. And civilization has only existed for about 6,000 years. And if we can create a terraform Mars that lasts for hundreds of millions of years, and that would certainly be an enormous achievement. And probably with continued human help, we could maintain it beyond that amount of time.
Thank you. And Dr. Lau, can you talk about, one of the questions that came in was about the psychology of travel to Mars. It's really interesting now that we are in this pandemic and most of us are pretty isolated from everybody else. And I'm sure there's a lot of therapists getting phone calls right now. Can you discuss how, the long travel, the close quarters, just the psychological part of it?
Absolutely. And I think that first, to your point that, right now during the pandemic, a lot of people are physically isolated. We are feeling alone. For anyone watching, I'm always happy to talk with anyone who needs someone to talk to. Reach out to therapists, reach out to people out there. There are people who will do therapy online. Mental health is so important, and it's something we don't talk about enough in our societies, honestly. And so, yes, if you need help, please seek help. It's really hard when we're physically isolated. That said, some of my favorite talks during this pandemic in 2020 have been from astronauts who have been sharing their perspectives of what it's like to be isolated for long periods of time on the space station in this environment that is not supportive of human life. Humans, we did not evolve to live in space. Space will kill us. And so we created an environment in the space station and in our spacesuits to survive there. But the astronauts are very physically isolated. They're in small groups together. And so we actually have had wonderful experiments, for the past 20 years plus of having humans isolated in very drastically dangerous environments like space. And so there's actually been a lot of research done on the psychology of surviving in these environments together, of what we can do to support each other in these environments. So all the astronauts on the space station are given some private time. It's known that everyone has a little private time to be by themselves, to look out the cupola or to read a book or just to be alone and be present with themselves and to not have to actually be at work or be with the crew. And there's a lot of other things that we've learned along the way. And with the Mars Society, with other groups interested in Mars, there are many analog stations now around the globe where people have been isolating themselves for weeks, months, even years now, and testing out these psychological experiments of what happens when you're alone with a very small crew. And we know that we can do it. We know that people can survive in these environments, but we also know that, again, mental health is so crucially important for us to talk about. And the first people going to Mars are likely going to have been well-trained in psychology and in how to deal with each other in this environment, because we don't want people going to Mars and then having, a breakdown and exploding on each other on the red planet. We need people who are able to work together, and when they have problems, know how to work through those problems together as a crew. And so the psychological impact of traveling to Mars, of being on the Mars surface, is going to be one of the most physically isolating environments ever when you're that far away from the rest of humanity. And so it's very important that we figure those things out. And as I said, we've been doing that research for a long time now. So there's already a lot done in that realm.
Thank you. I'm going to ask one more Mars-based question, and then I'm going to move to the founders and ask them some questions specifically about Mars University. There was a really interesting question, Dr. Zubrin, I'd like to ask you about regarding the Outer Space Treaty and space law, and how that affects going to Mars, settling Mars, claiming Mars, etc.
Well, there is a problem with the Outer Space Treaty. That is because it essentially, effectively blocks the development of private property in space for the most part. Yes, you can go to Mars right now or the moon and you can gather rocks and they're yours. Okay, but you can't stake a claim. So you can't develop land. You can't, and this is really important. I mean, let me give you an example. There was a few years ago a bit of a boom in asteroid mining companies, which got some serious investment for a while, but they all failed because they could not stake claims. Technologically, right now, you can't mine an asteroid. That is, we don't have the means to actually go to an asteroid and extract platinum or something and bring it back to Earth. But we do have the means to explore them. And if you could go to an asteroid with a spacecraft and explore it to some specified degree of detail, and in return were granted a mining claim to that asteroid, then such missions could be privately financed right now. But there's no legal basis for that. And so that intellectual property, which has served to make mining prospecting and oil prospecting a profitable business on Earth. A lot of people have made a lot of money, not drilling for oil, but just finding it for other people, staking the claims and then selling the claims. And so we need to have laws that allow such things, laws that allow you to transform knowledge into property. Because right now we are in a situation where it's possible. So for instance, let's say you had a probe that could look for geothermally heated subsurface water on Mars using ground penetrating radar. Right now you could do that, and if the government wants to do that as a matter of science, it could, but you couldn't get that privately financed. Whereas if you could actually stake a claim and then sell those rights to others, you could get such exploration privately financed.
Okay, thank you, Dr. Zubrin. I'm going to move to a couple of questions, again, for the Mars University founders and some more information about the university. And if we have time at the end, I'll move back to some more Mars based questions. One of the questions is for probably Bruce and Cole, and if Graham would like to jump in, he may. How did the founders and faculties come about coming up with Mars University? What motivated you? What inspired you?
Well, Cole mentioned the word Mars University to me, and my imagination went wild. And and then the two of us brainstormed. Okay, Cole, I'll give you a minute to think about it. Nicole, I thought you were going to ask me about my personal motivations leading up to it, and I'll digress a little bit. I got motivated by Jerry O'Neill and the space settlement ideas because he convinced me that someday we can have trillions of people living in colonies made from asteroids, or orbital settlements. 3,000 times the Earth's land area can be in settlements out in space. And the question is how to make the first one, how to get the first factory. And I realized the moon was not a good stepping stone to Mars and the asteroids because the moon doesn't have a lot of carbon and nitrogen and water. So in terms of permanent settlement, I think Mars is a stepping stone to the moon. And then, both of them are stepping stones to permanent settlement. And by the way, the stepping stone to Mars is ground-based research. We don't have to go to the moon to learn how to manufacture on Mars. So, and I think Mars University is a key part of that, getting people together in person, preferably, learning and thinking and talking about how to build on Mars. So, Cole?
Yeah, I love this question. So I met Bruce at IAC 2019 last winter, last December, and he was sitting alone at a table, and I approached him, and sure enough, we had a 2-3 hour conversation pretty late at night about Mars.
Cole, in my defense, I had a pack of pictures and I was ambushing people as they came by, and you were one of them.
Yes.
And so I showed you the pictures.
Yes. And, I started working with him for a few months. And then Dr. Robert Zubrin's book, A Case for Mars, really inspired us to start Mars University. And, the idea just kind of came to me one night before bed. I think it was like last January, and I couldn't really sleep. And the next day we just kind of just started trying to figure everything out. I wish we had a cooler story, but it's kind of what we have now. So thanks.
That is a cool story because most ideas just come to you in a flash.
If I could add one thing, Cole and I talked a lot about the International Space University. And at first we were saying we'd model MarsU after ISU. But after talking with Shannon and other people, we all want to make it more academically rigorous and much better structured.
Great. Good, thank you. The next question is, what is the selection process for the students? How are they selected?
I can try to take a stab at that. We're still trying to figure it out, to be very blunt. We're looking to hire a director of admissions within the next few weeks. And I'd also like to jump back in and address a question from CN in the chat. We're absolutely thinking about diversity. And it's a really important component in our admissions process. We're planning to reach out to a lot of schools and disadvantaged communities about the program we're organizing. So we'll definitely be able to provide more information about that on our website as well.
A lot of that is really for Shannon Rupert, but she is living in rural Washington and has a very limited bandwidth, and it's hard for her to join these. But she's taken the lead on academic planning, scheduling, and faculty. So,
And the fact that Mars University takes students worldwide, this isn't, you know, US only. Any student from any country in the world can apply.
Yes, yes, definitely, but it will be in English, and we hope to be located in Southern California. We're considering a few other locations too.
Yes, that was another question. Do we have a physical location? And I know that we are working with a few different places to get that physical location settled, correct?
Yes, yes, we've been having some great conversations with Arizona State University in Tempe, Arizona, in the United States, and so we'll keep you posted very soon.
Yeah, there's a couple places in the Los Angeles area that are under heavy consideration. But if people in the audience have suggestions, or if they know someone on the faculty or higher administration that would really like to be associated with their university, please let us know.
Yeah, that's a great point. We're absolutely open to hosting the program.
And we cannot pin down the cost until we pin down the location. So I'm sorry about that.
And that brings me to the next question. What are the fees? And if you don't know exactly, can you give the students a range and talk about the scholarship opportunities?
I can. I would love for this program to be definitely on the more affordable side compared to similar programs, and so we're continuing to discuss a range of $5,000 to $10,000, and it's really dependent on so many variables, and we're working hard to provide around 20 scholarships for our amazing students or applicants, hopefully soon to be students.
Okay. And so there was a question about the K-12 audience. Now, Mars University is geared towards at least sophomores in undergraduate and up. And there were also questions about master's degrees, PhDs. Anybody, once you've got your first couple of years of undergraduate down, anybody is welcome to apply to Mars University, no matter what your education level is past the first couple of years of undergraduate, correct?
Yes. So we want people to be entering their junior year or of college or graduate in graduate student. I personally would like to see a lot of young professionals or people of any age who are switching careers. A lot depends on who applies, and we'll see.
Okay, and let's see, I think we're getting to the end of our time here. Does anyone on the panel want to add anything, any last comments or share any links? Okay, any questions can be emailed. We are going to send out a follow-up email to all of the participants with more information. And if any of your questions are pressing, we had hundreds of questions, as you saw in the chat. Obviously, we can't get to all of them today, but you can send them as a reply to the email. And thank you all very much for participating in this inaugural Mars University Summit. And does anybody else have any? So I just typed the email in the chat. It's easy to remember. info@mars.university. There is no .com or .org in university. Just info@mars.university. Okay, thank you.
Yes, and my email will be on the slides as well. We'll send over.
Okay, thank you, everybody.
And
Thank
I see a little boy in an orange shirt who is one of our future Martians in the video. He's named M. Galgi too.
Thank you, everybody. Have a great day.
All right, thank
Thanks
you.
so much, Robert,
Bye.
and everyone.
Thank you, Robert and Graham and Nicole.